All right, so here we go. Part 2 of section 1.5. The guidelines, the instructions, the steps for finding the inverse of a function. Okay? First thing, figure out whether it has an inverse function. Don't go find it just to find out you wasted your time looking for something that doesn't exist. Determine whether the function does have an inverse function. So graph it, take a look at it, see if it passes that horizontal line test. I know that graphing is not a foolproof way of doing things, but it's better than nothing. Okay? Solve for x as a function of y. That is, solve the equation for x instead of y, because it should be given to you explicitly where it will be solved for y. Once you've got it solved, interchange x and y, and then the resulting equation should be the inverse. Okay? If you've done everything correctly. So if you're sure that it has one, once you interchange here, you will have found the inverse. Determine the domain and range based on the domain and range of the original function and go from there. All right, so let's go ahead and do that. I'm going to find and verify the inverse of this function. First off, I'm going to make sure that it exists. So root 2x plus 4. So I'm going to get rid of this guy. We don't need it anymore. And we have f of x equals, why did it go away? F of x equals square root of 2x plus 4. And so there's my graph. What do you think? Seems like as I go further and further out, that graph just keeps going up and up and up. Looks like it's going to pass that horizontal line test. I feel really good that this does have an inverse. I feel really good that this thing exists. So, step 1, yes, it does have an inverse. Now, I'm going to do something that's not listed in the directions from the textbook here. Because I know what's going to happen down here, I'm going to go ahead and figure out something right here. What's the domain of this thing? And what's the range of this thing? Right? Now, the domain of this thing is going to be when is 2x plus 4 greater than or equal to 0, which is when 2x is greater than or equal to negative 4. So that's when x is greater than or equal to negative 2. So my domain is the set of all x such that x is greater than or equal to negative 2. Now my range was set of all y such that y was greater than or equal to 0. And how did I get that? Well, a little bit of knowledge, a little bit of graphing. I looked at the picture, saw that it started at the x-axis and went up from there in terms of the y-axis. It started when y was 0 and went up, so that gives me my y greater than or equal to 0. Okay? Now I feel pretty good about step 1. Step 2 says, rewrite this as a function of y, and then solve for x. So y is equal to the square root of 2x plus 4, and then I'm going to solve for that x right there. Step 1, I'll square both sides. That gives me y squared is equal to 2x plus 4. Subtract 4. So y squared minus 4 is equal to 2x. Divide through by 2. Y squared minus 4, all divided by 2, is equal to x. At this point, according to the directions, this should be the inverse. So I can say that my g of x, which is y squared, I need to interchange my variables. X squared minus 4 over 2 should be equal to f inverse of x, because I'm to here. I did step 3 just now. And now I will determine the domain. So what is the domain of this new function? Hey, that's why I did this a moment ago, because the domain of this function is the range of the original. We just swap out that variable. Okay? And then the last step would be to do the verification process, to verify that what we've done truly is. So we need to do f composed with f inverse of x, like we did a while ago, and show that that is equal to x. Okay, we're going to question that. So let's see if I can find this. So f of x squared minus 4 divided by 2. I'm going to evaluate that. That's going to be, let's see, f says what? Root. So root of 2 times what's in the parentheses plus 4 Now, inside those parentheses, you see that 2 and that 2 are going to cancel. I'm going to get the square root of x squared minus 4 plus 4. And so I get the square root of x squared. And what's the square root of x squared? Well, normally I would say that's the absolute value of x. But I don't have to worry about the absolute value because of this right here. Right? The domain of this function is only x's that are greater than or equal to 0, and that's my inside function. So that is the domain of this composition. And because that's the domain of this composition, these absolute value bars are unnecessary, and I'll just make them go away. And I will say then, square root of x squared is x. I got my x this way, and now I'll just check the other composition and make sure that works. Inside the parentheses there, we got a square root. We're squaring it. The square of the square root is the radicand. And so I've got 2x plus 4 minus 4 divided by 2. Those cancel, I'm back at x. And so it worked both ways. And since it worked both ways, that makes it an inverse. And I've checked it. All right, last thing we have to do is take a look at the idea of inverse trigonometric functions. So we're going to consider a function that is not one-to-one on its entire domain. All trigonometric functions fit this definition, or fit this description. All trigonometric functions are not one-to-one on their entire domains. Because all trigonometric functions are not one-to-one on their entire domains, they do not have a inverse function that exists for everything. We have to do a restriction on that inverse function to make it work. And because we have a restriction on that inverse function, to make it work, to make it have an inverse, we got to work hard to make this happen. Right? Now, we talked a little bit about this in the last section. In section, what was that? 1.4. And so we'll take a look at it again. Here's the graph that I drew before. This was sine. Right? We said it failed the horizontal line test. So we do a restriction. We say only care about this little piece of it. And now it passes the horizontal line test. And if you're wondering, this is what the graph of the arcsine looks like for that same little piece. Okay? The domain of the arcsine, negative 1 to 1. The range of the arcsine, negative pi over 2 to positive pi over 2. Right? Now, the other trigonometric functions, all 6 of them, have this issue. These are all the graphs down here for the arc trig functions. I wouldn't stress too much about knowing them, but what I would be concerned about is knowing that they exist. There are issues whenever you use an arc trigonometric function in any calculation. You got to stop, spend a few minutes thinking, did I screw this up? Or is this going to work just fine? Okay? If you're wondering about that and you didn't make it all the way to the end of section 1.4's video, I would suggest watching the last piece of section the part 2 of section 1.4, because that's where we went over it several times. Arc trig is a bugger. It's a pain. It has issues, and we have to adjust for those issues. Okay? Those issues arise just simply because math only wants to work sometimes. And this is a situation where what the math needs, 1-to-1, is not what trig gives us. Trig gives us issues. Trig gives us too many places where this function is not 1-to-1, and we have to fix it. And so we fix it, and we do this for every trigonometric function out there. Okay? All right, this brings us to the end of section 1.5. There's one more section, I believe, isn't there, 1.6, in this chapter, but we're almost done with chapter 1. So hopefully you're keeping up with the homework and you're keeping up with all the work. You should be somewhere middle of the second week at this point. All right. Have a good day, and I'll see you for section 1.6.